ingeniero Eugenio Marín, quien es ingeniero mecánico, egresado de la UNAM, especializado en mecatrónica. En 2004 fue cofundador de una startup en alianza con una compañía alemana dedicada al diseño de ingeniería e integración de sistemas para el sector aeronáutico. Cuenta con más de 17 años de experiencia en el desarrollo de más de 800 pymes mexicanas de base tecnológica en su escalamiento internacional, desplegando modelos de aceleración comercial y estrategias de penetración de mercados en Estados Unidos, Canadá y Europa. A través del programa Technology Business Acceleration, ha creado redes en sectores como las TICs, en aeronáutica y defensa, en tecnologías de salud, manufactura avanzada, ingeniería, marketing online, etcétera. Desde 2006 ha sido consultor asociado de la Fundación México-Estados Unidos para la Ciencia en tópicos de innovación, comercialización de tecnología y escalamiento de startups. Actualmente es el director ejecutivo de esta fundación, la Fundación México-Estados Unidos para la Ciencia, y previamente responsable del Centro de Productividad e Innovación 4.0 en Querétaro. Ingeniero, ¿si nos puede escuchar?
¿Qué tal? Muchas gracias
Adelante.
por tenerme aquí. ¿Sí me escuchan bien?
Sí, perfecto.
Sí, excelente. Yo voy a honrar la cortesía que Genji se inició, por supuesto, para que no dejemos fuera al doctor Dimitri. Así que voy a hacer también mi presentación en inglés. Pero antes de eso, solamente pues agradecer la invitación. Estoy muy honrado de participar en este coloquio. Eh, eh, en memoria del doctor Kussul, quien es una persona que ha sido fundamental en todos los que estamos aquí, no solo en la parte académica, sino en la parte humana. So I will start saying this, and this is very important for me because this group that everybody's talking about, the micromechanics and mechatronic group that was formed by Dr. Kussul with Alberto, with Polo, this amazing group was very, I would say, important in my life. And I can tell you why. First of all, I started my internship in 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 Secadet back then and I want to say this as an informal intern. And I don't want to say illegal, but informal. And this is why, because I couldn't start my internship, formally speaking, within the engineering faculty, because I was probably 1 year ahead when I could start doing it. So, but I was looking into different groups of research and development around the university, and the only one that kept my eye and was in the back of my head every single time was the work that was being performed at Secaret, and particularly in this group, because I was doing my research, I was visiting labs, different labs, the Engineering Institute. I was to I was visiting as well some programs at the science faculty and the nuclear energy institute. I mean, I was doing my research, and very early in my career and in my bachelor's degree career, and it was probably in the mid of my journey. And then I decided to go to the center, and this center, first thing I noticed was that the laboratory where this group was working was not in the main facility, and I think Beatriz already said a little bit about that, and Alberto already mentioned that as well. I didn't know the politics back then regarding the center and that specific group, but the main facility was not hosting the group, and then there was like a small laboratory besides the main facility. And for me and for my colleagues back then, even though we didn't know about the politics and what was happening in reality and what this group was segregated from the main facilities, for us it was like an elite group working on very high-end things and very interesting things. So we felt very proud of being part of this group. And the first thing I did was to go. I went there, I knocked the door. Leopoldo opened the door, and I just asked, can I know a little bit more about of what this laboratory all about? I'm very interesting. I'm very intrigued of a couple of articles and information I found on the web about your work. And so he was very kind. He received me. He gave me like half an hour, 1 hour. We're discussing what they do. And I said, well, I think that I'm not ready to formally join the laboratory if I can apply to be an intern. But if there's a chance, I would like to start right now. And I don't know what happened between Leopoldo and Dr. Kussul. Probably there was a small discussion about it. And probably Dr. Kussul said, it's okay, he can come. And, instead of, but he has to work. That's for sure. He's not going to be here just looking at us he has to work. So I started working this way. I started going into my internship. I took it very seriously. And all of a sudden, I was part of the group, and I learned a lot. I can tell you, and if you can see from the previous comments of Dr. Dimitri, and for example, what Beatriz was mentioning about those walks, and Henkis as well, these walks were amazing for Dr. Kussul because we all noticed that in those walks, some ideas came out and some discussions, some profound discussions were conducted. So when I was, trying to understand the lines of work, the research, the big questions of the technological development that was being produced, I understood a couple of things. We were doing a very small part of a big spectrum of technology development that was happening around the world. And all of a sudden, I started realizing that specific work that we were doing was not colliding, but probably, getting into a point where it was confusing for some other research groups of where the convergence or divergence from other technologies would be with the micromechanical approach. For example, the micro electromechanical systems, the nano electromechanical systems back then, MEMS and NEMS were very interesting technologies based on integrated circuits, and lithography and photolithography and all those manufacturing procedures to get interesting results. And the thing was, where is there a convergence, or these technologies are so apart that they're going to come to a different place in the near future? So that was something very shocking to me. So one day in those walks where Dr. Kussul was outside the laboratory, I went out with him walking and posing this question to him. Do you really know when and how we can predict the convergence of micro machining and micro technologies with all these other research groups doing MEMS and NEMS and even the Japanese group that Henkis was talking about? They had a different approach of how doing micro technologies and using some of the computing power to control those systems. So it was very posing to me, and I asked Dr. Kussul about it, and he said, "Well, this is a very, very difficult question because we don't know yet. We're in the middle of understanding how these systems are working, how they're going to be applied into the resolution of the different problems, and the technology is still in early development." So I said, well, for me, this is very important because I think if we can move along the needle in terms of pushing the limits of this technology, then we're going to be certain of how this could converge or diverge from that, the other technologies that are getting all the attention, all the budgets from big universities in the United States, in Canada, and in Europe. And there was a big movement around them. So that was one of the first things that it was very interesting to me, because it was not only technological driven, but it was market driven. And another thing was going back to what Dimitri mentioned, some of these interesting contributions from Dr. Kussul to the scientific development and technological development are still to be, discovering in how to be applied. And some of these ideas are very important nowadays, with all these semiconductor geopolitical shifts that the world are happening and are having, and with as well with the renowned needs of getting back to the production of critical technology for certain countries, especially North America. This is very key and very important, where these technologies could help the markets, the industries, in order to gain position. And Mexico certainly is one of the critical countries where this reshoring and manufacturing is coming back in certain ways. So research development and the workforce development as well is very important. So and I see this as a critical point. Is this type of ideas and technological development is going to be very, I would say, critical for the future. And just sharing a little bit of a different anecdote. If you go to the next slide, please. When we were working on different aspects of this microfactories, the microfactory development in Japan, the micro machine generational theory that the group in this laboratory was developing, we understood that there was something very important: the combination of technologies and the criticality to not be performed in perfect ways. And I remember one day I was staying very late at night at the laboratory, working on components, mechanical components, and doing some CNC machining. And I was very frustrated because those components were not, getting the dimensions, the perfection that we were looking for. And all of a sudden, Dr. Kussul was back there in the door and saying, "What are you so frustrated about it?" I said, "Because these particular components need to be with this precision, and we're not getting it with these machines. Even though we had good machines, we were not getting the precision needed." So he said, "Don't worry about it. That's why we have, automatic control. That's why we have programming. That's why we have other tools to compensate the natural errors of materials." And that's when I realized he had a tremendous impact in how his approach in terms of building machines, in terms of getting the precision out of some pieces or some components that are not performing in the way that they are supposed to. And even though, because they're not designed in the right way. And that's another point that Beatriz mentioned was, keep it simple. That was very important for me in the mechanical design process, to keep things as simple as possible with the less degrees of freedom in terms of, the simplistic designs usually work better. So that's something that got to me very clearly from Dr. Kussul, was don't get frustrated with the processes. Start looking at how to compensate and how to get to the right control of things. Machines are designed in that way, to be controlled and to produce what you're expecting, but then you have to measure, and then you have to go back and produce feedback to the machine and start doing it again and again and again. This was a systematic approach of getting results, and that was amazing. I mean, for me, it was freeing my frustration in the laboratory. So I just wanted to share with you a couple of phrases that I got from some of the articles and some of my work that I did. But and I'm going to read this in Spanish, but I think that you have it in front of you. Y esto es un homenaje al doctor Kussul por ser esa fuente de inspiración profesional y de vida que realmente pues muy pocos ingenieros han dejado en mí, y fueron semillas, pocas conversaciones, pero muy profundas. Y por supuesto también agradecer al doctor Leopoldo, a Beto, por toda la formación que nos dieron a ese grupo de estudiantes. Gracias por esa amistad, por esa calidez, y porque siempre estuvieron presentes en el trabajo que hacíamos, tanto a nivel de tornillos como a nivel de trabajo científico, ¿no? Y a todos los compañeros que estuvimos por ahí. Por ahí yo no salgo, pero creo que estoy ahí al final del laboratorio. Al frente están dos de mis colegas más apreciados, pero básicamente, bueno, pues es algo de lo que recuerdo muy bien en esos días que estuvimos trabajando en el laboratorio. So just to finalize my comments regarding the work that Dr. Kussul was doing, I remember that some discussions he had with the research group back then was not only mathematical models, was not only about manufacturing, was not only about artificial intelligence and neural networks, but as well as how to convey a good product. And I remember that he was very keen on saying that he started his career as well in the Navy, well, in the Russian Navy or the Ukrainian Navy, something like that. And he was working on boats. And he shared with me a couple of stories regarding that work that he performed back then. And he said this was crucial. This was very important, because sometimes creativity doesn't come just by sitting and thinking how to solve a problem. Sometimes creativity comes because you're stressed out to survive. You're stressed out in war. You're stressed out because you don't know if you're gonna live one more day. So sometimes human creativity is pushed to its limits, and there's where things happen and the magic happens. The neurons and your thinking is wired to survive. So sometimes that's very important. And he was pushed to some of those limits when he was working for the Navy, and for those problems, solving technical problems for the Navy and those boats. And it was very important that story to me, because it's so true. And we see this in countries like Israel, in countries like Ukraine, that are, having this troubleshooting problems, political and geopolitical aspects of it. But anyway, humanity is like we all know that we are very complex, and we don't want to solve everything at once. But technology certainly, and technology and science certainly are very important human tools to try to appease those type of problematics in the world. So with this, I just want to thank you, everyone, again, my colleagues, my co-workers back then, and my mentors, not only Dr. Kussul, but as well Leopoldo, Alberto, they're present. Thank you very much.
Muchas gracias, ingeniero.
Thank you,
Bueno,
Eugenio,
ahora nos